Let's take a look at the fundamental theorem of algebra on a TI-82 calculator. And our first problem we'll look at is this one. The instructions say to find the zeros. When I say find the zeros, they mean set that equal to 0. So we're going to have x to the third minus 3x squared minus 18x plus 40, and we'll set it equal to 0. Now we're going to put our polynomial on y1, and we'll put a 0 on y2, and we're going to solve this partially using the calculator. Now our largest power tells us how many answers we're going to have. So third power tells us we're going to have 3 answers. Well, let's go ahead and put this into our calculator. Okay, so press y equals, press clear if you have anything there. Do your x key caret 3 minus 3 x key x squared minus 18x plus 40. And then I want to down arrow to y2 and put a 0 there. This process does not work if you don't have a 0 on y2. We're going to do second trace. I want to choose intersect, and you see there's a 5 in front of it, so I'll go ahead and press 5. Now our answers are where it crosses the x-axis. Looks like -4, 2, and 5 maybe. In the lower left-hand corner it says first curve. You just press enter on that. Then it asks us for second curve. You just press enter on that. Now for our guess, we're going to take our left arrow key and push it over and over until we get our cursor over closer to the one we're trying to find. So we're trying to find this one, so I move it over closer to there, and once I get it over there, then I'll press enter. And it comes back and tells us that x equals -4 is our first answer. Well, we said we're going to have 3 answers, so we'll go through this process 2 more times. I'll do second trace, do 5 for intersect, enter on first curve, enter on second curve, and I'll do my right arrow key, and I can hold down the right arrow key and have it quickly go over. And I want to move it over closer to this next one, which looks like about 2, and then press enter. And that gives us x equals 2. Now you don't have to be right on top of it, but you don't want to be too far away either. This is pretty easy to get it close to it. So let's find our last one. So do second trace, and choose intersect, 5 for intersect, enter on first curve, enter on second curve, and I'll hold down my right arrow key until my cursor is over closer to the one I'm trying to find, right there, and then press enter. And it comes back and tells us our third one is x equals 5. Now, our largest power is x to the third, our degree. It means we have 3 answers. We found all 3 via the calculator. So we're done with that problem. Let's take a look at our second one. Okay, I want to find the zeros again, so we're going to set it equal to 0. So we got 4x to the third minus 17x squared plus 16x minus 3 is equal to 0. Now, our largest power, the degree, is 3, means we're going to have 3 answers. So let's go enter this in. So I'm going to press y equals, clear, 4 x key caret 3 for my 4x to the third minus 17 x key x squared plus 16x minus 3. And you have to have 0 on y2, which you should already have it there, so you don't have to bother putting it there again. Now I'm going to do second trace, choose 5 for intersect, and looks like it crosses at, I don't know, 1/4, 1 and 2, 3, maybe 3. I'll do enter on first curve, enter on second curve, and you see that my x value is 0, my y value is 0, so it's sitting at the origin now. And that's closest to that answer I'm trying to find right there. So I can just go ahead and press enter. And it comes back and tells me 0.25. Now this is a pretty easy one to change to fraction form, but let's say it wasn't so easy to see. To change a decimal to fraction, we exit out, so we do second mode, and first notice that it's in x equals. So again, I did second mode, exit out. Now push my x key, and then math, enter, enter. That comes back and tells us 1/4. So our first answer is x is equal to 1/4. Well, we got two more answers, so we'll go through the process again. Do second trace. I press the 5 that's in front of the intersect. Enter on first curve, enter on second curve, and I'm going to move my cursor over close to the one I'm trying to find, that one right there, and I'll press enter. And it comes back and tells us x equals 1. And we got another answer, so let's see what else we can find. So I'll do second trace again, choose 5 for intersect, enter our first curve, enter our second curve, and I'll move my cursor over closer to this one, and press enter, and it says x equals 3. Now our largest power was 3. That said we're going to have 3 answers. We found all 3 via the calculator, so we don't have to do any extra work. Let's look at our third example. This one here. Want to find the zeros. It means we're going to set this equal to 0. So I got x to the 4th plus 5x to the 3rd minus 5x squared minus 15x plus 14 equal to 0. Okay. Again, we're going to put the polynomial on y1, 0 on y2, just like before. So let's enter it in. We'll go to y equals clear. X to the 4th, so I do x key caret 4 plus 5x to the 3rd, so x caret 3 minus 5x squared, so minus 5, my x key, and then x squared, minus 15x plus 14. You should still have a 0 on y2, so you don't have to re-enter that. So I do second trace, choose 5 for intersect, and looks like, I don't know what that is, -5, -6, something like that. Anyway, you have to wait till it comes back before you start pressing enter. Okay, now it says first curve. So we do enter on first curve, enter on second curve, and I hold down my left arrow key, move my cursor over close to the one I'm trying to find. Trying to find that one, so I'll press enter on it. And we get a -5.316625. Well, we don't want decimals at all, so let's try to change this to a fraction. It's stored in x, just like before, so I'm going to do a second mode to exit out, and press my x key, math, enter. Now I won't change to a fraction, so we can't use that one. Well, let's go see what we can find. I'll do second trace, 5 for intersect, enter our first curve, enter our second curve, and I'll press my right arrow key and move it over close to the one I'm trying to find, even though I'm pretty sure it's -2. And then press enter. And it comes back and tells us -2. Okay, well, let's continue. Oops, don't want that. So I'll do second trace again, choose 5 for intersect, enter on first curve, enter on second curve, and I'm going to do my right arrow key to move the flashing cursor over close to the one I'm trying to find. Now I see this goes down below my x-axis a little bit and goes back up, so there's 2 answers right here. And I'm on the left side of those right here, so I know I'll find the one on the left when I push the enter. And that tells us x equals 1. Well, I know there's 1 right beside it, so I'm going to do second trace again and choose intersect. Again, our answer is where it crosses the x-axis. Enter our first curve, enter our second curve, and I'll do a right arrow key to move it over to the right side of those. So I'll find the one over on the right. Now I'll press enter. And we get another decimal, 1.3166248. So we know how to handle that. We're going to exit out and try to change it to fraction. So do second mode, x key, math, enter. And it doesn't change to a fraction, which is no surprise. If you get one decimal and will not change to a fraction, you'll have a second one. Well, all we got from our calculator was 2 answers. Well, let's work with that. We're going to now plug those into synthetic division. And this video is not about showing you how to do all of this. It's showing you how to integrate technology with the process. But I'm going to take the -2. Now, we're starting out with x to the 4th. Okay, go through a series of adding, multiplying over and over till we're done. 1 plus nothing's 1. You always multiply a number in a box by number you put down here. Negative 2 times 1 is negative 2. Add, 5 and negative 2 is 3. Multiply, negative 2 times 3 is negative 6. Add, negative 5, negative 6 is negative 11. Multiply, negative 2 times negative 11 is 22. Add, negative 15 plus 22 is 7. And multiply, negative 2 times 7 is negative 14. And then add, 14 minus 14 is 0. Notice we get a 0 here. That means we found an answer. That's no surprise. The calculator told us was an answer. You better get a 0 there. Now each answer you find takes it down one more power. This was x to the 4th, so we're now down to x to the 3rd. And we're going to plug in our second answer. We said 1 was our second answer. And I want to plug it in the line I just found. So I'm going to continue this process. I'll add 1 plus nothing's 1. Multiply, you always multiply by number up in the box, by number you put down here. 1 times 1 is 1. Add, 3 plus 1 is 4. Multiply, 1 times 4 is 4. Add, negative 11 plus 4 is negative 7. Multiply, 1 times negative 7 is negative 7. Add, we get a 0. So that told us we found an answer. So x equals 1 is our second answer. Again, no surprise. Calculator tells you it's an answer. You have to get a 0 there. Each answer we find takes it down one more power. So this was x to the 3rd. We're now down to x squared. This is x. And this is no x, our constant term. So we're going to have x squared plus 4x minus 7 equal to 0. And we're going to have to use a quadratic formula to solve this. For a quadratic formula, a is whatever's in front of your x squared, which is invisible 1. b is whatever's in front of your x, which is a 4. And c is your number at the end, which is negative 7. Quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Probably find it easier to plug in parentheses everywhere you have a variable before you plug in your numbers. So I got negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Well, b we said was 4, so everywhere I have a b, I'll put in 4. A we said was 1, so everywhere I have an a, I'll put in 1. And c we said was negative 7, so everywhere I have a c, I'll put in a negative 7. Okay, so we got negative 4 plus or minus 4 squared is 16. Negative 4 times negative 4 times 1 is negative 4 times a negative 7 gives us a positive 28. All over 2 times 1 is 2, which gives us negative 4 plus or minus 16 plus 28 is 44 over 2. Always in algebra we should simplify our radicals before we go on. 44, if I do the prime factorization of it, is 2 times 11 over 2. Remember, the square root, we're looking for pairs of something. Here's a pair of 2's, so this pair of 2's is going to come out in front as a single 2. So we've got negative 4 plus or minus 2, and then we're left with 11 inside. Now remember the quadratic formula. If you can divide this number, and this number by the same number, do so. Well, those are all divisible by 2. So that's going to give us negative 2 plus or minus 1 square root 11 over 1, dividing everything by 2, which just gives us negative 2 plus or minus square root 11. The reason why they were decimals that would not change the fractions is they were really radical answers. Now, we circle 2 answers up here. The plus or minus here counts for our other 2 answers. So that gives us our 4 answers we were looking for. Okay, let's look at our fourth problem. Again, we want to find the zeros of this. So we got x to the 4th minus 6x to the 3rd plus 30x minus 25, and we're setting it equal to 0. If you're finding zeros, you set it equal to 0 and you solve it. Well, let's go input our polynomial in. So I'm going to press my y equals clear. X to the 4th, so I do my x key caret 4 minus 6x to the 3rd. So minus 6, then my x key caret 3 plus 30x minus 25. Okay. Now we'll do second trace. Choose intersect, 5. Our answer is where it crosses the x-axis. Looks like -2 something. Gotta wait till it comes back before you start pushing your enter. Otherwise, you can hang it up. And if you hang it up, you just press on to get it unhung. Okay, it's asking us for first curve, so I do enter. Asking us for second curve, so I do enter. I'm going to do my left arrow key to move my cursor over close to the one I'm trying to find. We're right there. And press enter. -2.236068. That doesn't look promising, does it? But let's try to change it. You never know. So we'll do second mode to exit out. Now push my X key, math, enter. Yeah, it doesn't change. I didn't think it would. So now we'll do second trace, choose intersect, enter our first curve, enter our second curve. Our next one looks like 1. And again, I'm going to do the right arrow key, move my cursor over close to the one we're trying to find. So I'll put it right there and press enter. And it tells us 1. Okay. Well, we got a couple more. Next one looks like 2 point something. So let me do second trace, choose 5 for intersect, enter our first curve, enter our second curve, and I'll move my cursor over close to the one I'm trying to find, right there, and press enter. 2.236068. Again, doesn't look promising, does it? But let's try it. I'll do second mode, exit out, X key, math, enter. Doesn't change. No surprise. You get one decimal that won't change, you get a second decimal that won't change. Well, let's find our last answer. So do second trace, choose 5 for intersect, enter our first curve, enter our second curve, hold down my right arrow key to move this one over close to the one we're trying to find, and press enter. And we get x is equal to 5. Well, we need 4 answers. We found 2 via the calculator. It'd been nice if we got all of them. Let's start plugging these in. Okay, so I got 1, -6, 0, 30, -25, 0. Where in the world did that come from? Well, remember this is x to the 4th. This would be x to the 3rd. This would be x squared. This would be x, and this would be no x, our constant term. Remember, you start with your largest power, and you have to have 1 for each one going down. The fact we were missing the x squared, we had to put a 0 there. Okay. We're going to go through a series of adding, multiplying over and over till we're done. Add, multiply, add, multiply, add, multiply, add, multiply, add. We get a 0. Again, no surprise, the calculator told us that was an answer. So you better get a 0 there. So our first answer is 1. Well, let's plug in the other one. Put in 5. And I'm going to continue on the line I just found. Now we started out as x to the 4th. We're now down to x to the 3rd. Okay, so we're going to add, multiply. 5 times 1 is 5. Add, -5 plus 5 is 0. Multiply, 5 times 0 is 0. Add, -5 and 0 is -5. Multiply, 5 times -5 is -25. And then add, 25 minus 25 is 0. Again, no surprise. Calculator told us has an answer. You better get a 0 there. Each answer we find takes it down 1 more power. This was x to the 3rd, so we're now down to x squared. This is x, and this is no x. So we got x squared minus 5 equal to 0. And again, we're setting it equal to 0 because that's what we're doing, is we're finding zeros. So you're always setting it equal to 0. Now in this one, our middle term's missing. You notice we got 0 for the x component. When that's true, you can use square root property. So I'll take the -5, move it to the right side. And the square root property says if you got something squared equal to the other side, then you can drop your squared and put a plus or minus square root around the other side. Now the reason why they wouldn't change to a fraction is, again, they were radical answers. And the plus or minus counts for 2 answers here, so we just found all 4 answers. Okay, now let me look at one that typically causes problems. This isn't on my PowerPoint. It's just one I'm making up out of my head. And let's see how the TI-82 handles it. TI-83, TI-84 is a little bit flaky on how to handle it. until y equals clear. Do a beginning parentheses x minus 2. I don't expect good things from this. And then I'll do a squared. So again, just type it in exactly as I see it. Okay, now if I do second trace and choose intersect, it looks like it's coming down at x equals 2 and going back up. I don't see the graph anywhere below my x-axis, so it looks like it's touching at a point. Well, let me do enter on first curve, enter on second curve, and for my guess, I'm going to do my right arrow key to move it over closer to that, and then press enter. Error sign change. That's interesting. I do enter on quit. Let me try it again. Second trace. Let me choose intersect. Enter on first curve. Enter on second curve. Let me try to get a little bit closer to 2. That's probably about as good as I'm going to get without zooming. And now let me press enter. Remember what I said, that it does weird things when it touches at a point. When it touches at a point, you're looking at the graph and you get an error sign change on TI-82. Then what that means is x equals 2 is an answer if you can visually look at it and see it. It even means more than that. Usually when it comes down and touches at a point, it means that it's actually 2 of your answers. So you'd have x equals 2 and you'd have x equals 2. Anyway, something to keep in mind as you work in a problem. You'll have a little bit of trouble with the ones that touch at a point. And those are the ones that repeat. Now that's finding or using the fundamental theorem of algebra using the TI-82. On my website, let me go to it. Where is it at? This is www.mathheals.com. You can find more videos. Currently, the link says graphing calculators, but I'll probably change that to graphing calculators / technology. But you can go here, and then by subject, you can look it up. Like I look up college algebra, and you can see videos for various models of the calculator. I'm going through and creating them for all the different ones. So when I have students come in and they have a different model of calculator, instead of me telling them that they're out of luck because I know nothing about it, I can point them to this reference. You can also see where it says math class information. If you go under that, then you can see full lecture videos. The same ones I give in my classroom, you can watch them out here if you need extra help on it. Anyway, that's using the fundamental theorem of algebra to help find zeros with the help of a TI-82 calculator.